Okay, hi everybody. Okay, so we continue in the second video. So in this second video, we would like to find how we evaluate a limit. Okay, so how do we evaluate a limit? Okay, so this is the key point. Evaluate means you should give a numerical answer. You should give an answer. So how do we find that answer? Okay, there are a few techniques for evaluating limits. The first one is substitution. Substitution is, let's say you have you want to find limit f(x) x approaching 2. So you just substitute number x equals to 2 inside your f(x) to find the limit. Number one. Number two is factorization, where we simplify first the equation. Number three is we multiply with the conjugate, its conjugate. This is called as the conjugate method. Okay, we will look through one by one. Okay, so the first one is finding limit x is approaching 0, x squared minus 1 over 2x plus 3. So this is our fx. Okay, so this is our fx. So by substitution, we just substitute x equals to 0 inside. Okay, we substitute inside our fx, so it becomes 0 square minus 1 over 2 multiplied with 0 plus 3. So you get negative 1 over 3. So this is the limit. Okay, very easy, kan? Alright, but substitution won't always work. Okay, some fx you can't directly substitute your x value. Okay, for example, like this. If you are given limit x approaching 2, x squared minus 6x plus 8 over x minus 2. So when you substitute 2, you will get this 0 over 0. So once you find 0 over 0, if you get this value, this is what we call as indeterminate form. Indeterminate form, 0 over 0. So from here, you have to choose either these two methods. You have to choose either these two methods. The first one is by factorization. Second one is the conjugate multiplication. But in this case, we will use factorization, because from here, if you look at the numerator function, this is actually you can factor out, kan? So how we do? We factor out. So x squared minus 6x plus 8 can be written as x minus 4 multiplied with x minus 2. So what happened is this x minus 2 we can cancel out. So you left only x minus 4. And now back to substitution. Okay, we substitute 2 inside your x minus 4. So you will get 2 minus 4 equals to negative 2. Okay, so that is the limit. Okay, what is the conjugate method? This is number 3, kan? What is conjugate method? So usually conjugate method we apply when we have a function that having set inside usually. Okay, because we want to remove that set, kan? We have to multiply with its conjugate. Okay, so for example, this question, limit x approaching 16. So when you substitute directly x equals to 16 inside, okay, you substitute x equals to 16 inside, you will get 0 over 0, which is the indeterminate form. Okay? So next step is to choose these two methods. You have to choose either one. Alright, factorization very hard to factor out, kan, this function. Okay, so what can you do is we multiply dengan dia punya conjugate. Okay, conjugate the above conjugate, the numerator. X minus 4 set x minus 4. This one also set x plus 4 over set x plus 4. Okay, and then what happened is you will get x minus 16 over x minus 16 set x plus 4. So this one can cancel out. So you left only 1 over set x plus 4, where you substitute directly x equals to 16 value inside x. So you will get 1 over set 16 plus 4. Set 16 is 4, so 1 over 8. Okay, so what if you multiply with this one, we change to set x minus 4 over set x minus 4, set x plus 4. Okay, this one is we follow a square minus b square. We can change to this form kan, a plus b, a minus b. So same thing. This one also you can cancel out. So you left only limit of x approaching 16, 1 over set x plus 4. Same thing. Okay, pun boleh. Either one, sama. The final answer will be the same. Okay, 1 over 8. Okay, what is infinite limits? Okay, what is infinite limits? Meaning that when you substitute, when you check your x value, okay, when your x is approaching a constant, okay, your answer here is infinity, positive infinity or negative infinity. Previously, you get a constant, kan? A constant value. But in this case, you get infinite limit. Okay, meaning that when x is approaching some value, your fx is approaching positive infinity or negative infinity. Okay, for example, all right. So we would like to find if you look at here, this one kan, if you look at here 2x plus 1 over x minus 3, before we find the limit itself, okay, from here the function itself, we know that this is your x cannot be 3. Your x can be any number except x cannot be 3 kan. When you substitute x equals to 3, so you will get this answer 7 over 0. 7 over 0, 7 divided by 0, you will get undefined kan. Okay, fx is not defined at x equals to 3. So this case is actually indicates the presence of vertical asymptote. There is a vertical asymptote. Okay, for example, in this case, the same equation, x cannot be 3. So 1, 2, 3. Vertical asymptote is in this case is this line, vertical asymptote. Okay, where your function, your fx or this fx will not cross this vertical. Okay, so x can equals to 3 is the vertical asymptote. Okay, if you look at the green car, where is it? Green car, oh no, green car, this one kan, green car. So when x is approaching 3, okay, is approaching 3 positive kan, your graph is going up, is approaching positive infinity. So this is what we call as limit, infinite limit. Limit x approaching 3 positive fx is equals to positive infinity because your graph is going up. Okay, but for the other side, when limit x approaching 3 negative, okay, fx, so your graph is going down, going to negative infinity kan. So meaning that here the answer here is approaching positive infinity, this one is negative infinity. So this is what we call as infinite limit. Okay, I think that should be clear enough to explain how we get that infinite limit. Okay, positive or negative infinity lah. So still infinity, this one also infinity because it's going down. All right, so limits at infinity, limits at infinity. So this one is to find when x is approaching infinity, fx. Okay, we will get a value, the limit at infinity. What happened to your fx value when your x is approaching infinity? Okay, so we will look at the next video. All right. Okay, see you in the next video. Yeah, thank you.